Hi, my name is Prakash Gupta, and this is my Physics 2 Lab 3 video lab report. Introduction. This lab concerns circuitry and particularly some analysis of DC and RC circuits, and we'll be using the PHET Circuit Creation Kit tool to simulate these circuits. First, let's look at the DC circuit. So we can see here that we initialized our circuit with two 1.5 volt batteries, two ammeters, and two resistors at 47 and 100 ohms each. The readings on the ammeters match, as you can see here, independent of which direction it is, that you have to kind of look at it upside down to get that direction on the second picture. And they're also corresponding roughly with what we would expect per Ohm's law. 147 ohms, because the resistors are in series, times 0.02 amps is approximately equal to 3 volts, which is what we would expect per Ohm's law. When we take out one of the ammeters and replace it with a voltmeter, we see that there is no amperage because the circuit's not closed, but we do have a voltage of 3 volts throughout the entire part that's there. And this makes sense because voltage measures a potential, and so between there and there, there's a lot of potential, and if we connected it, we would have a circuit, and that would be flowing. Now, when we close that with a wire, the voltage drops because there's no voltage over that wire, because that's now the closed path, closest closed path. Now, when we look at the picture again here, the ammeter shows that we do have some current, and that makes sense because now, of course, circuit's closed and the electricity's flowing. Moving on, we wanted to check the voltage over several different pieces. We see that the voltage over the battery is 3 volts, as we would expect, that there's no voltage over the ammeter nor over the wire, and that the voltage over each section of the resistors adds to 3. And that makes sense. That's consistent with what we would expect, because the net voltage over the whole circuit should be 0. Now note that it reads positive 2.03 and positive 0.97 because I'd accidentally swapped the lead on the voltmeter. But if the red-black order was consistent throughout, we would see that either the 3 would be negative or the 2 and the 0.97 would, and that would give us our sum of 0 overall. Moving then into the graph of voltage over time, or well, over position, we see that we go up 1.5 when we get the first battery, and then again when we hit the second battery. And then we're consistent until we hit the first resistor, which in my drawing was the weaker one. So we go down a little bit, and then we go down the rest of the way after we go through the second resistor. And that remains for the entire time. And we know this is correct because, because we know that if we were to duplicate this, our start and our end voltage are the same. Moving now into the RC circuit, we see originally we had the light bulb turn on very briefly when the energy from the battery flowed through the light bulb into the capacitor, and then it shut off, as you can see in the current picture. Now, when we remove, you can also see that the charges on the two plates of the capacitors have been filled. And this is why it stopped, because once we hit capacitance, there was no more flow of energy. Now, when we removed the battery, all of the energy that was stored in the capacitor was discharged and the light bulb lit up. I wasn't quick enough to catch a picture of that. But then after the charges were depleted, you can see the plates are now empty. We have that the light bulb switched back off. Moving now into our questions. What if you were doing this experiment in real life and used an actual ammeter instead of an ideal simulated one? What's different about a real one, and how could it have affected the circuits that we hooked it up to? So an ideal ammeter is not going to have any voltage draw, nor any amperage draw, nor any resistance. And obviously, none of that is true in real life. So we would have seen either we would have seen a drop, or sorry, we would have seen a reduction in amperage as we would have had an increase in resistance, um, while having a equal voltage from the battery. Now, what if we were doing this experiment in real life and we used a real battery to charge a real capacitor with no resistor in the circuit? How quickly would this ideal model? This ideal model would predict that the capacitor reaches full charge immediately, and that's not how it works in real life. In real life, it takes time for charges to flow and for a circuit to charge a capacitor. And that's all. Thank you very much.